So this is a really nice normal distribution applet calculator that allows you to put in the mean and sigma, which is standard deviation, the mean and the standard deviation of any normal distribution. And remember, that's kind of the address of the normal distribution. As long as you have those two things, you know everything about the normal distribution that there is to know. And then the x is like the raw score. And then here we have just some options in terms of shading. So let's jump right into an example. We had talked about the height of adult females in the US in a previous video, and I think it's the average height is 5'6", I believe, which would be 66 inches. And if I remember right, the standard deviation is about 3.5 inches. So let's say, now we have our distribution here. Let's say we want to know what portion of adult females in the US are less than 6 foot tall, for example. So 6 foot would be 72 inches. So I'm going to do 72 right there. And notice that this is already designed. Here's that 72 inches mark. We can see these measurements in inches. And the shaded portion is the entire portion that would be shorter than 72 inches, or 6 feet, the portion of adult US females. We have the probability here, or proportion. We can change that to a percentage pretty easily by saying, moving the decimal over and saying 95.7%. About 95.7% of adult females in the US are shorter than 6 feet. We can also flip that around and say, hey, what portion are larger than 6 feet or taller than 6 feet? And we could subtract this from 1. You also have the option in this calculator of just saying that you want greater than whatever your particular raw score is. So this would tell us about 4.3% of adult females in the US are taller than 6 foot. You can, let's see. You could also do things with the standard normal distribution, or the Z-score distribution here. Remember that that's a very specific and special normal distribution where the mean is 0 and the standard deviation is 1. So this distribution right here is the standard normal distribution. And if we wanted to say, figure out, say, how many, what portion of the distribution is less than 1 standard deviation above the mean, we could do this. So there's 1 standard deviation above the mean on the standard normal. In other words, that's a z-score of 1. And we can see that 84% of the distribution is below a z-score of 1. In other words, their z-score would be less than 1. Now, you might vaguely remember the empirical rule, which says that 68% of the distribution is within one standard deviation. So why are we seeing 84? Well, that 68% says 68% of the data is within 1 standard deviation of the mean. Here we have all this data on the left that's beyond 1 standard deviation below the mean. So if we wanted to trim that off, we could say the portion that's in between 1 standard deviation below and 1 standard deviation above is 68%. And if we did 2 here, we're going to see that 95%. You can see it's actually 95.5, but 95% is a great rule of thumb. And then here you see that 99.7% is within 3 standard deviations. So if you are working with z-scores, all you need to do is put your mean as 1 and your mean as 0 and your standard deviation as 1. So this is one tool to use with the normal distribution. A second tool that you could use is Google Sheets. And Google Sheets, especially if you need to do a bunch of calculations, like you want to calculate the z-scores for everything on the sheet, for example, or where those z-scores fall in the normal distribution, you can just use a formula. So we type here an equal sign, and then norm dist, and we would put if we click on the question mark, by the way, you can see all the you can see that we'll be putting in our raw value, the mean, standard deviation, and then cumulative we'll just put in 1 or true. That means we want the entire area up until whatever that cutoff is. So let's do the same calculation we just did for the women's height. So we wanted to know what portion of women in the adult US females are shorter than 72 inches. So we would put 72, and then we put in the mean and standard deviation. So this would be, mean was I think 66, and the standard deviation was 3.5. And then cumulative, just go ahead and put 1. That'll give you the entire area to the left. And that should look familiar. That's what we found on our applet calculator also. So 95.7% of the adult females in the US would be shorter than 6 foot. So this is another thing you could use. Another thing you could use is, get it here, norm. Notice that before we did norm dist, there's also norm s-dist, which would be the standard normal. So now all we're going to do is put in a z-score, and it'll tell us what portion of the standard normal distribution is less than that z-score. So if we put in 1, a z-score of 1, we get that 84%. Again, going back to that applet, remember that if you look at 1 standard deviation above the mean, and then take everything to the left of it, all the way even beyond 1 standard deviation below, you're picking up that left tail as well. That would be 84% of the standard normal distribution. So that's norm S, S for standard distribution. And finally, what if you wanted the opposite? Let's say we wanted to know, maybe you had a goal of being within the top 20% tallest females in the US. So here we have a percentage that we're dealing with, and we have the mean and standard deviation, but we don't know what the actual height is that would get us into the top 20%. So if we do norm.inv, now this might look familiar from a previous spreadsheet when we were generating them. And then here we need to put in the percentage. So I'm going to make a mistake just to show you here. So I'm going to say the top 20%, and we know that the distribution, the mean is 66 inches, and the standard deviation is 3.5 inches. So this seems to be suggesting that to get in the top 20% tallest females, adult females in the US, you have to be 63 inches. Well, this is 5 foot 3 inches. If something feels off there, it should. And this is one of the reasons I like the applet. So if we would put, again, 66 here, and we put 3.5 here, and we put that 63 inches we just found, it looks like, oh, and we do this, it looks like about 20% is below that. We want to be up here. We want to be in the, we want to find the height that gives us 20% above and 80% below. And that's the key. And you can see that visually on this app. If you go into the spreadsheet, it's a little trickier to see that and to realize that whenever you use this formula, you need to put in the portion to the left. It's always dealing with to the left. And if you want the portion to the right, you're going to have to adjust that separately. But the portion to the left would be 80%. So if you're talking about the 20% tallest women, that's the same as being above the 80% of shortest women. And that gives us a height of 69 inches roughly. And if we go back to the calculator and put 69 inches, here you can see that roughly 80% is shorter than that. And if we flip it around, we can see that indeed 20% is above that. So in order to get in the top 20% tallest females in the US, you'd have to be above 69 inches or so.